Recently, a customer contacted us regarding waveform jitter or misalignment. This is a common question and concern we receive from Plexon users. Luckily, Offline Sorter has the functionality to closely visualize the data, which will help to understand this jitter or misalignment. We created this video to show how to use Offline Sorter to visualize what is happening and to demonstrate a few things that can cause the misalignment. We will use this example to demonstrate these points. This customer contacted us to say that they had recently encountered what appeared to be waveform jitter on channel 5. They also found this apparent misalignment in another channel in this recording session. Here's a screenshot of channel 5. First, it is important to understand how the waveforms are visualized in Offline Sorter. By default, waveforms are aligned to the threshold crossing. It is possible to change the alignment point, but by default, and in many circumstances, alignment to the threshold crossing is fine. One way to better visualize what is happening in this example is to enable the center selected option in the timeline window. This will allow the user to select a waveform in the 2D clusters window and snap to its position in the timeline view. This can be useful to see the signal around the extracted waveform. This visualization becomes more powerful by decreasing the amount of time shown in the timeline view with the Zoom In button. With these options selected, the user can select a waveform in the 2D clusters view and visualize it in the timeline view and the waveform view. Here is an example. Notice a green waveform was selected by left-clicking in the 2D clusters view. That waveform is visible in the waveforms view and in the timeline view. With these options, the user can quickly visualize the waveform within the tight clusters visible in the 2D clusters view. Doing so illustrates the jitter originally described is due to a poor threshold setting. In this example, one of the waveforms outside of the green cluster was selected. As seen in the timeline view, the threshold was likely set too close to 0. A small deflection in the noise directly before the waveform caused it to be prematurely triggered. It is likely that the waveform in question should be included with the green unit. However, the pre-trigger means its PCA values position it outside of the green cluster. When sorting via an algorithm, it will likely not be correctly sorted into the green unit, and further analysis of this waveform's activity will be inaccurate. Here is another example that demonstrates the importance of setting a correct threshold. A threshold too close to the noise could result in many prematurely triggered waveforms. The poor threshold setting also affected the yellow unit. Here is an example. This is a waveform selected from directly below the yellow unit cluster. This waveform was prematurely triggered, like the other examples. Fortunately, most modern acquisition systems allow for the continuous unthresholded signal to be saved. One benefit of this is it allows for the user to re-threshold the data offline. For these examples, doing so with a threshold further away from the noise floor would ensure less jitter and tighter clusters, which will make for better sorting results. We hope you found this example helpful, and if you have any other questions, please email us at info@plexon.com.